Welcome YouTube to another Eagle Auto Repair tip and strategy. I just want to thank you for joining me. We're going to be talking about overlaying a circuit today. We've got a Jeep Grand Cherokee 2006 where the wipers have failed. We could go in and try to isolate the short and find the circuit, but I've got this great product that I want to show to you. And in the video, what we're going to do is we're going to overlay a circuit. So I'm very happy that you joined us, and we'll get it right into the video. I just wanted to take some time to welcome you and again try to help those out there that are working on their vehicles. Maybe you're a professional mechanic, maybe you are a backyard mechanic, maybe you just like finding out information about your car. So I've been doing this for a long time. I've been working on cars since the 1970s, and I just want to share some of my information that I've learned over the years. Trial and error, some of the heartaches I've been through, and try to get you down the right path, help you get your car fixed and not have to spend hopefully a whole lot of money or time. So I enjoy question and answers. Please feel free to submit some questions. So I'm going to show you this product first of all. This is called, I don't know how you pronounce it, it's SOPOBY. It's a solder and seal connection kit that you can get. I'll put a link in the video so you can check this out, but it's just a great product. You know, years ago they came out with a butt connector, just a plastic connector with a metal piece inside. You put it in, you splice it. The problem with those are we need weather sealed connectors, especially in today's electronics. This is a 2015 Acadia, but we're going to be working on a Jeep. So we need to seal those connections when we make them, when we open a circuit. So it's very important that we don't poke any wires with our test light to damage the insulation, and also that we get a good seal if we open a circuit up. So we don't want to have corrosion or any resistance that would cause the circuit to fail or the device to not work based on a changing resistance or a voltage drop. So this is a really great product. Normally we use in some cases we'll even use a copper type band, splice band, and the normal fix would be you use that, then you solder it, and then you're using heat shrink to seal it. But this product kind of incorporates all of those things in one neat little package. Like I said, I've used it here. It's a great product. So I'm going to get close up with the camera, change the angle, and we're going to demo how this works. When the connection is made, they have a test that they show. I believe on the Amazon link you can even see that video of the strength it'll hold. The only thing that I would be concerned with here is because you can make this melt basically with a heat gun, low temperature. Minimum temperature it says is 80 degrees Celsius. Minimum temperature for the solder to melt is 138 degrees Celsius. You know, I would be worried about putting it next to a heat source because you wouldn't want that to fail to melt on you. So that's probably something to consider. But we're going to go ahead and dig into this and see if we can open that circuit. We've got to first get that harness opened up a little bit. Looking for some side cutters. They've got a on the harness, you can see here they've got a little zip tie to keep the connector in place. So we're going to have to remove that. And our circuit number, it's A5 again is the circuit. And you can see it right here. We want to strip this back a little bit. The harness exposed here, we're going to have to get to that A5 circuit. So they've got a little bit of tape on the end of the harness. We'll open that up because we want to move away from the terminal without disturbing the connector end. So we'll cut back some of that tape that we'll end up replacing when we close this harness back up. But we just want to expose that circuit a little bit. So we'll move some of this fabric back that protects this harness, just so we can get a good look at that wire. There's the wiring harness, and it also has tape wrapped around it to keep everything nice and neat. Take that off. And this circuit just happens to be right out in the open. It's this end one here. It's actually this terminal number 25. When you look at the connector, that's how you find it's number 25. And it's this purple, or I'm sorry, red with a violet tracer. So we'll move down into here, into this area here. We'll open that circuit up. And we're going to strip the wire back a little bit. Like that. And then we will add our new wire with the circuit breaker installed. Just kind of overlap them right there into the solder. And we got our heat gun ready. Let's see how these connectors work. We're going to warm it up. Get that solder to start to melt. You can see the heat, the shrink tube is already reacting. And we'll get it nice and sealed on the end. And it looks like the solder is starting to melt. I can see it running up the wire a little bit. Try and get a better angle so you can see it. All right, I'll let that cool down. It looks as though the solder kind of ran into the wire. So it should be a pretty good connection. We're going to let it cool down for a minute. And just check it out. It should be a good weather-tight seal. So far, I'm pretty happy with it. So let's just see here how this works. So you can see right here where the heat shrink tube is pretty effective. That solder melted and did what it was supposed to do. We're going to take a little, I'm tugging on it pretty hard. That looks like a pretty good connection. I'm pretty happy with that. So yeah, we're going to go ahead and get this back together and make sure that our circuit repair is complete. We'll put some power to it and we'll check the wipers and see if they're working. We used our SOPOBY connectors, our heat shrink terminal connectors. We've got that circuit repaired. Everything's back together. Try to get a little camera angle here so you can, I don't know if you can see the wipers, but we're going to key it up. We've overlaid our circuit. I ran that circuit breaker back into this fuse box. Tape that wire up so it's kind of neat. We don't want any wires hanging out anywhere. That'll also protect that a little bit. We used our heat shrink tube to make sure at the ends that we have good waterproof, weather-tight connections. And we're going to turn the key on and see if the wiper motor is running. All right, so there's our overlaid circuit. Try to get it on high here so you can see the motor right here. And we do, in fact, have the wipers going. There it goes, it's on high. Relays are powered up, they're right here. Our overlay circuit is successful and everything is working like it should. So perfect. Get them to park. Turn the key off. And now I can finish putting the rest of it back together. So again, here's a situation where when we look at the schematics, we figure out where the problem's at, right? Back probe. Went inside, tested for voltage at the circuit breaker that was originally installed out of the factory in the junction block fuse panel inside on the firewall. And now, because there's a circuit failure somewhere between that point and our relay, wiper relays out here, instead of trying to find where that's at and, you know, tear it all up and lay, you know, figure out where it's at, particularly what we did was we just overlaid a circuit. We refer to that as overlaying a circuit. So we found a power source close to the relay, and we figured out which terminal, which circuit it was in the connector at the bottom of the PDC, or the integrated power module, I believe they call it on these early ones, and just supplied power and made sure our circuit breaker is still in place, so the circuit's protected. Remember, fuses in circuit breakers are not, they're there to protect the circuit. So when there's too much amperage overload, the circuit opens up. In this case, the circuit breaker would get hot, it would open up if there was a problem. Prevents the wires from melting down and further damage. So, yeah, so I'm pretty happy. I'm pretty happy with the product. I'll put a link to this in the description below for this product here. It seems to work pretty nice. Like I said, I've done a lot of CAN circuits, you know, and I would use that on a CAN circuit. Again, I might be hesitant around certain high temperatures, like exhaust or things where it could come in contact. So just, you know, in the event that solder heated up again, we don't want it to heat up and be a problem. So, but in this application, I think it works really great. We were able to get it looking nice and tuck it right in there. So pretty happy with it, and I'm sure the customer will be as well. So again, thanks for joining us. This is Vince from Eagle Auto Repair. And again, as I say, I just, you know, want to offer up information, try to help you out. Been doing this for a long time. So if there's anything you can, you know, hit me with some questions. I'd love to respond and help you through your either electrical or mechanical, whatever the problem is. I've always, you know, worked bumper to bumper, top to bottom. I've specialized in some areas throughout the years. I do a lot of electrical stuff right now. I'm an electrical consultant, technical consultant for one of the major corporations. And yeah, so I'd love to help you out and steer you down the right path. So give me a like or dislike if you don't like the video. I'm open to suggestions. Hit me with some comments. You know, I want to help you out, so think about subscribing to the channel. I'll do my very best to bring you quality material, and hopefully I'll get better at it as we go. And yeah, so I just want to thank you again. And as I always say, have a blessed day.